So we're continuing to look at the analysing the centre, and we want to look at the middle 50% of our data. So the middle 50% is what goes between the lower quartile and your upper quartile. So if I've got a box and whisk graph like this one, we've got our minimum and our maximum at the two ends, we've got our median in the middle, and then we've got our upper and lower quartiles at the edges of the box. So that distance there, the distance between the lower quartile and upper quartile, that's our middle 50%. And it's called the middle 50% because 50% of the data lies between those two quartiles. Because quarter, remember, divide the data into four pieces. So essentially we've divided our data into four pieces. We've got one piece here, which is the tail down the bottom. We've got one quarter here, which is between the lower quartile and median. One here between the median and upper quartile, and one here between the upper tail. So there are 1, 2, 3, 4 quarters, and 2 quarters together, which is our box there, 2 quarters make 50%. So that's how they get the middle 50%. So we need to look and identify where this middle 50% is. So let's start by looking at our backs. So I've drawn a blue box there, and you can see that is the middle 50% I'm referring to. I'm going to read off the values for our upper and lower quartiles. So our lower quartile is at 88 kilograms, and our upper quartile is at 96 kilograms for our backs. Then we do the same thing for our forwards. So there's the middle 50% of our forwards, and that goes between 104.5 kilograms and 117 kilograms. So those are the values that I want to report on. So for achieved, I'm just making a quick note of these numbers. Oh, and it should be 104.5, I think. Yes, 0.5 rather than 0.8. So that's me just making a typo. So I'm going to be able to say that the middle 50% of the forwards weights are between 104.5 kilos, that's my mistake, remember, and 117 kilograms. Whereas the middle 50% of the backs weights are between 88 and 95.5 kilograms for our sample of rugby players in New Zealand and South Africa, because that's our sample that we've got. And so that's what we need to be able to write for achieved, as they go between this and this. So what is it that we need to do now for merit? So we've got the same picture here, okay, and what we want to do now for merit is look and see, is there any overlap between those? And I've drawn this lovely red box here which shows us that there is quite a big gap between the forward weights and middle and back weights for our middle 50%. So there is definitely no overlap of weights in the middle 50% of those two groups. And that's what I want to be able to write for my merit. So I'm going to be able to say, looking at that graph and our summary statistics, we can see there is no overlap of the middle 50% between the weights of forwards and backs. So then what about excellence? Okay, thinking about again back to telling the story. Did we expect it to overlap? Why did we expect it? Didn't we expect it? And refer back to research if we can do it. So I'm going to start by looking at the role of backs and the role of forwards. And we know that backs need to be fast and agile, so that means they're likely to be smaller and lighter because it makes it easier to run faster. It's not true of everybody, and that's when Jonah Lomu was an exception. Okay, but he's an unusual. It's unusual to see somebody of his size playing in the back position. Whereas our role of forwards is to be strong, make lots of tackles, and so they need a lot of strength and muscle and weight to anchor the scrum. So that is why it makes sense that the middle 50% of forward weights are larger and don't overlap, so that they are different types of players than the backs. And there we have it.